All right. Sure. Okay. Hi, everybody, and welcome to the January Indie Tech Talk here at the Game Lab at NYU. For those of you who haven't been here before, this is a series of talks that's run by the Game Lab and Baby Castles. My name is Ben Johnson. I'm an organizer at Baby Castles. I also run a small game studio in Brooklyn called Dozen Eyes with my friend Phoenix Perry. We do usually about one of these a month. We get people from who are local to New York and also from across the country and occasionally internationally to come and give talks about sort of interesting ideas going on in game development, especially if there is sort of a tech side to it. For those of you who don't know what Baby Castles is, we're a group that focuses on getting game developers to work creatively with artists and musicians and other people who are sort of outside of the traditional spheres of game development. We run a gallery that is on 14th Street in Manhattan. It's between 6th and 7th Avenue. You should look us up at babycastles.com/website. Or you can look us up on Facebook as Baby Castles. We do events there periodically. We just finished an exhibition that was actually the piece of immersive theater. If you're familiar with Sleep No More, it was kind of like that, only it was a sci-fi musical. It was called The Universe is a Small Hat, and it did pretty well. So we were really glad to have that. We're working on setting up the next exhibition. Yeah, thanks, Guy. Yeah, it was pretty good. Anyway, we're in the process of switching over to the next exhibition, which I guess I'm not supposed to say what it is yet. But one of the other things that we're doing is Baby Castle is going to be making a video game, and while we're doing that, we're also going to be running the gallery space as a free game developer co-working space on weekdays, kind of between 11 and 5. If you're interested in coming and hanging out with us while we make a video game, or you're interested in making video games, or you want to help us make a video game, you can do that. You can just look us up on the website to figure out what's going on there. But anyway, thank you all so much for coming. The people we have with us tonight, Nina and Emmett, are people that I've known for a couple of years. I know both of them actually originally from game jams, I think. And it's been so cool to watch them develop as game developers over the last few years. I'm really excited for this talk, and I hope that you are too. So would you please help me welcome Nina and Emmett?
Hi, I guess we should introduce first. So I'm Nina, as Ben said, and I make video games. I do primarily design and programming.
And
this is Emmett.
I'm Emmett. I'm a web programmer during the day, and I'm a game programmer on weekends. I program a lot, and me and Nina work together on a lot of different stuff.
Yeah, so we did together with other teammates, we're against Sybil. We did How Do You Do It, Ladylike, Space Dad, and a couple of other games. So we've worked together for a while. So I'm going to talk to you today about this game that we're working on now called Cibele. So here we go, Cibele. I'm designing and programming for the game. Emmett is programming. And Cibele is an autobiographical vignette game about a girl who has a relationship with a boy in an MMORPG. And an MMORPG is a massively multiplayer online game, for those of you who aren't familiar with the term. The game, Sybil, follows this pair's relationship as they become closer and closer romantically until they eventually decide to meet up and have sex. So we've been working on this game for about 7 or 8 months, kind of like in the heat of development right now. So we're going to talk about sort of what's brought us here, so like early development stuff and some of the technical challenges that we've faced. And just as a note, I'm going to be referring to Nina throughout the presentation. And when I refer to Nina, I'm not talking about myself. I'm talking about the character in the game, just so you know. OK, so this is a picture of the prototype, which is really ugly. So the prototype for Cibele was developed in a class with Bennett Foddy at NYU Game Center last spring. And in the original prototype, which this shot's from, my goal was to give the player a structure within which to explore the story of this online relationship that I mentioned through mechanics that embody this experience of interacting with a love interest in a digital space. So I wanted the player to understand how it would feel being in the situation as Nina. Players were put into Nina's shoes, prototype, by sort of overhearing her flirt with her love interest, while also controlling her avatar, which is like that little black-haired girl in the corner. And there's also a little chat log to kind of give some atmosphere to suggest that it's an online game. So the design has since been refined to better support player character embodiment, which I'll talk a little bit about in a minute. But the general idea of playing as Nina in this online game and controlling her avatar in it has proved to stick. So I'll show you a little trailer of the game as it stands right now, so you can get kind of a little bit of flavor of it. And then I'll show you a little gameplay. Hey, what's up?
Let's just private chat. Sick of all these fuckers in the main channel.
By the way, Star Maid Games is like our team name, and I'll mention the other members of the team in a second. So this is sort of a little video of some of the gameplay as it is right now, that sort of comes after the bits you saw in the trailer. So the player plays as Nina, sort of navigating her desktop as you saw in that trailer, logging into the game, playing the game, and interacting with her lover. So the player controls that blue dress avatar, and you may have noticed there was like a little purple avatar also wandering around, and that's sort of the guy that she's playing the game with that she has a thing for, or a thing with. So those are sort of the two main characters. One is an AI, and Emmett's going to talk a little bit about the AI stuff that we've done, and then obviously the player controls her. So this kind of, I wanted it to mirror the experience of playing an online game, but I wanted to also simplify that as much as possible in order to help the player focus on the relationship between the two characters. Because if any of you have played World of Warcraft, any of those online games, they can be really kind of heavy. There's like a lot of stuff, a lot of UI. There's just like a ton going on, a ton of other players. So we kind of wanted to strip it down to a very simple look, sort of simple style. So that's what you're seeing here. And we did that in order to sort of emphasize player character embodiment. So the embodiment of the character Nina. So I wanted to make this game for a couple reasons. First, I'm really passionate about making brief and concise autobiographical games. And Sybil is entirely autobiographical and is based on an experience I had as a teenager playing an online game. Second, I'm interested in exploring the potential for player character embodiment within vignette games. So the goal of Sybil is to help players embody an experience outside of their own. The player's not telling their story through gameplay or through the character of Nina or anything, or seeing themselves in or through the game. The player embodies the main character, Nina, through mechanics designed to link their hands to her hands, their eyes to her eyes, etc. So since this is a tech talk, I thought it would be interesting to briefly address technology in Cibele as a concept before we get into the actual implementation of the game. So Cibele is a game obviously built using technology, but it also acts as a way of examining how technology mediates human relationships, or at least that's like a goal of the game. And I don't want to get into specifics of how we do that sort of throughout the game because it would spoil the story, but I'll speak generally about why I'm so interested in technology's impact on human communication and interaction. So, as I mentioned before, I played an MMORPG. I played Final Fantasy Online for a solid 4 years when I was in high school and a little bit in college. And I had a lot of formative experiences within this digital space, making friends, flirting, growing, and learning more about myself. I've thought about my time spent in this game a lot as I've grown up. And it's been interesting realizing more and more the impact that the relationships I had in that game have had on my life. So, however, I've found that the idea of online relationships, especially between people in online games, are often stigmatized. I've had many experiences explaining my online relationships to people, especially after working on this, only to have them tease me about it. So I think that the internet is one of our main mediums for communication. Well, I don't think that. That's just like a fact, right? So I strongly believe that all interactions within this space should be examined and taken seriously. And working on Cibele has really helped me understand that and motivates me to be open and honest about my experiences with relationships in online games and online in general, because it's just something that's not talked about as much as it should be. So once I decided to develop Cibele a prototype, I assembled a team and picked a platform. So Emmett joined at that point to help program. We're also working with Decky suited sound for How Do You Do It and a lot of other games I mentioned. Rebecca Dunlap is doing art. Samantha Corey is a filmmaker, and she shot the short films that are in the game. And we have a voice actor called Justin Briner, who's in Texas, that did the voice of the male character. Am I missing anyone? No. So that's sort of the team that I assembled post-prototype. And so we decided to use GameMaker Studio. The original prototype was in Flash. And I was like, okay, we're going to do this whole thing. We're going to use GameMaker, which is a tool for developing games. And I hadn't used it before, but I thought it would help speed up development since it has so much core functionality tailored specifically for making 2D games. And I wanted to kind of be able to iterate as fast as possible. So I was like, oh, I'll use this tool. So we ran into a few challenges in GameMaker really quickly. First, GameMaker is really a black box. When you use their built-in game objects, you can't exactly go in and see or modify the code that builds them because the software is proprietary. You can add on to GameMaker's objects using their scripting language, but it gets pretty annoying to add functionality to something that you don't and can't fully understand because you can't read the code that runs it. And second, GameMaker had no video support. And as you saw in the trailer, we use a number of short films throughout Sybil, and the lack of video support was a deal breaker for us as far as GameMaker. So then we decided to switch to Flash because we know it really well. We've used it for basically all our other games prior to that we've made together. And we can use the Flixel library, which we use to speed up development. Flixel is great because it's not a black box, it's open source. And we have since heavily modified Flixel to our needs, which has been really great. And that's something that GameMaker would not have necessarily allowed us to do with building these big plugins and whatnot. So I'll let Emmett get into more detail about all this stuff. He's going to go through some of our challenges, and just so that everyone knows, because I know a lot of you haven't played this game, he's going to talk a lot about the male character who is an AI and the player who's that girl in the blue dress. And it's sort of each level is one big kind of map. Think of a game like an old Game Boy Zelda game or something where you're exploring a big map. That's sort of the structure that you're seeing in that video, just so everyone's clear, because otherwise it might be confusing. And I'll pass it to Emmett.
Hi, everybody. I'm Emmett, programming on Cibele. So I'm just going to talk about a few specific challenges that we met on development and sort of later on as well, just to kind of give a picture of how we've approached problems while doing this game, because it's not anything else we've made before. Just before that, I wanted to note that my personal approach to developing it has been basically one of iteration and collaboration. I usually start with some partially defined set of requirements from Nina and Rebecca, the artist. I build an internal version of a feature based on the requirements, but it's pretty small, pretty prototypal, I guess. And really quickly after doing that first pass, I'll show the whole rest of the team and get feedback on how it works, right? This seems a little bit like in general, software development has come pretty far since the 1970s, and everybody knows that waterfall doesn't work. So obviously we're doing this, but it's kind of also unavoidable because everybody is going to know what you're doing on such a small team as ours. It's kind of just impossible to get around the fact that everyone's going to see and comment on everything that you do as soon as you do it anyway. So I'm kind of embracing that as I go, basically. So these are three particular things that I want to just touch on. They're kind of interesting development stories. fun challenges. First one is the fact that the play areas that we wanted to support were just gigantic, larger than anything we had attempted before in a game, and kind of how we address that. Also, making a convincing AI for this player character, which is the love interest of the actual player's character in the game. It's this secondary character who's supposed to be an avatar controlled by a real person. And also, the most recent one that we've solved is specifically how to make the character's movement as smooth as possible, given these like gigantic play spaces and the specific movement scheme that we've designed. So the first one is gigantic level maps. This was very early in the development. We were like starting to set up the basic structure of this thing, and we kind of wanted to know what we could, how large of a space we could support, because we wanted to have these giant worlds that you can't really explore in just a few minutes. Like we wanted, minimally you to be able to walk around these things for like 3 or 4 minutes without ever getting to the same place twice, to feel big, right? And also the artist draws these things all as single images, like these gigantic, like 10,000 by 10,000 pixel images that she's basically a digital painter, so this is kind of how she's most comfortable working. So the requirements are basically like support her way of working and also just make these things gigantic. Of course, the naive approach is to just load the whole thing at once, which we tried because it would have been really nice if that just works. And that's what we've done before, because it always works when your game is like 400 pixels wide or whatever. Like, how do you do it? One of our other games, like you can just do that there, but like here you can't. The entire thing is 10,000 by 10,000 pixels. The first time we tried it, it actually completely locked up this laptop, attempting to load this gigantic thing into flash runtime memory. So very quickly we were like, well, this obviously isn't going to work. So I know from experience in doing other stuff, like just, generally when you run into something like this, one of the first things you want to try is just splitting it up. You could do some kind of streaming thing or something, but I was just like, let's try to split it up into tiles. An actual tile map wouldn't really work with the artist's art style, because we wanted these whole maps to be made up of completely unique pieces. We're not going to like repeat tiles, so that was kind of out. But basically, the idea was we're going to break this thing up into tiles. Before that even became possible, I needed to collaborate with the artist and actually, show her what I meant by this idea of like breaking the thing up into squares. And then before I could run the code that tried it, like that used that stuff, it had to exist. So it was kind of this weird back and forth of like a chicken and egg situation where we need the art to write, but we need the code to truly know what art we need. So there was a little bit of tension going on there. But we ended up with this thing that I very creatively called the background loader. It's basically an ActionScript class that knows the location and like current velocity of the player character, the one that you're clicking to drive around. And it also knows about this giant set of tiles that the artist created for us. And basically, this is familiar. Like I didn't read any papers about this or anything, but I think it's pretty familiar to other 2D games of this type, where basically the idea is this loader is essentially predicting where you're going to walk next. You've got a tile loaded on screen, so you're not looking at like blackness, and around you, presumably, there's all blackness on the edges of the screen where you can't see it. And as you walk in a direction, before the blackness will become visible, it loads one of these tiles, so that you get the effect of this giant space that you're walking around. But in reality, there's only the only parts of the map that are being loaded are the parts that you actually need to see because you're there. Additionally, we've got these fun things, which are the collider tiles. They're really small versions of the map that are fully opaque black for the parts that you can't walk on, and fully transparent for the parts that you can walk on. And they're loaded sort of sequentially right behind the visible tiles, and we do pixel perfect collision with that little red box there. And so this is like basically this is a pretty good fulfillment of the requirement right now. The player experiences this whole giant expansive space without us having to load it ahead of time. And since we're only loading exactly what is needed by the player, there's no waste of space and like memory, and there's actually a minimal performance cost on like frames per second during gameplay. This is just a really straightforward example of like what I mean by the colliders and the regular map tiles. The top is like what we had the artist divide the entire thing up into, and then she also figured out how to use Photoshop to create these. And the bottom ones are actually pretty manual, because obviously you can't just like select by color in the top one to create the bottom one. So she has to actually more or less go through and draw these colliders herself, but it's kind of what we're stuck with given our requirements here. So this was our first one. Very quickly, we realized that this game is technically unlike anything we've made before because we've done very small Flash games, and immediately upon trying our normal sort of strategy, it just like crashes our computers, and it's like, well, all right, we need to sort of think about this in a different way. The next one is making this AI convincing for the player character, the love interest in this game. The requirements for this one are basically, we want to make it essentially as convincingly as possible. It should be an avatar that's controlled by a human player. So things like going after enemies very aggressively, leading and waiting for the player to follow, and also kind of having tics or something like, people in like Counter-Strike something in the loading area, like jumping up and down or something like that, right? This kind of thing that experienced gamers will do. We kind of thought that's part of the personality that we want to portray in this character. So that's something that we also wanted to like make sure that we support in the software that we write for this AI. And I'm all too familiar with state machines at this point because I use this basic design in every single game that we've made. I think there's some character that has a bunch of different states, and we implement it with essentially the same thing. It's been evolving, and sort of my approach to it has been sort of refining over the years that I've done this. But the basic idea, what I mean by state machine is, first of all, you define a bunch of these things. Just a set of states that are mutually exclusive in time to each other, meaning you can never be in two states at the same time. Just one for each thing that you ever want this character to do. Things like idle, walking, following an enemy, attacking, any other action that you might want the character to do. These are the ones that we have in our game, but obviously they could be anything. This is some extremely abstracted game loop code that illustrates what I mean here. The while true here is essentially like the abstract version of the average game loop of a game, and you'll define the steady state behavior of one of these just by saying, like, if state is this, do the thing that you do. If state is walking, walk, right? If state is attacking, do whatever attack means, And in addition to defining the steady state there, in the state machine, we'll also define transitions to other states. So this example is like, if you were walking and you're now at your destination, then move into the idle state, right? And usually when I write these, I put the steady state and the transitions in two different blocks so that it's really clear, because this stuff gets out really, really fast because I haven't, I've played around with better ways to do this than just a bunch of conditionals, but it's hard to generalize that to the point where I'm going to reuse it from game to game. So I've stuck with this for now, but it does get a little bit insane. This is like a tiny section of the actual AI code for this thing. And this is the parts of the code that I'm least proud of. So I'm showing it here to force myself to fix it. But this is, we've got like, move to map node, right? State null, idle at path node. It's like, they just like blow up in complexity. So as we iterate further on this game and other games that we make, like I'm always thinking about ways to make this better. This is currently the best thing, but I will say that this part of our game right now is the most bug-prone section of the code because of how it's written. That said, this has like worked pretty well for prototyping and stuff. So, I kind of think I like the idea of it being of a DFA technically. It's not, technically it's not, but the basis of this is what we call a deterministic finite automaton, which I just thought was cool. So that brings me to the last one, which is my favorite. Getting the character to walk around smoothly. We've got this pixel perfect collision going on with these really small images, the collider images behind the map, right? And requirements for this one should not be able to walk through the collidable parts. Instead, you should be limited to the pathways that our artist has drawn. And also, the player should never get stuck on a wall or this is the big one, attempt to walk through a collidable area.
And it's all point and click, by the way.
Yeah, this is all point and click. So we want to specifically avoid the situation where you can click on the other side of a wall and have the character just trying to walk the wall forever. That's like, you could do it. You can make characters in any number of games do that I can think of off the top of my head. But for this one, we didn't want that to be possible because it kind of created an atmosphere that we didn't want to represent. So the naive approach first, of course, as the crow flies, meaning you click and the player just walks straight there. It works fine for some things, but obviously it creates that problem. The character will try to walk through a wall infinitely, which is just not a great experience. Our second attempt was to just try to iterate on that first basic idea, adding stuff like heuristics and sort of little polishes. A big one included augmenting the collision detection that we had available to us to, instead of just saying, am I colliding, yes or no, be able to detect what side you're colliding on. And this actually had to be implemented, which was pretty annoying to do because it's supported by either Flixel or Flixel Power Tools, which we were doing for pixel perfect collision. So I had to do that myself. But it does enable, having that direction information about collisions enables an algorithm that actually lets the player kind of like slide around curved walls. Still can't walk directly around a wall that you're clicking into. But if you kind of click next to a wall and you're sort of hitting it, you won't just stop dead. You'll sort of slide along it, which is an improvement for sure. And we lived with that for a while. But the big issue is that the player can still just tell the character to walk through a wall and they'll just happily do it forever. And we play tested it a bunch, and this was one of people's main complaints, actually. And I was kind of like, man, I worked so hard on this stupid directional collision thing. It's like, oh, I don't want to, whatever. But people, a lot of people were telling us that it really takes away from the experience. And specifically, Ben Body recommended that we implement A-star pathfinding for this. And A-star itself is actually the easy part because it's a known pathfinding algorithm, but the harder part is generating the graph is input to this algorithm in the first place. So just really quickly, background on A-star for anybody who might not know. Pathfinding in general is a family of algorithms that takes a graph as input. A graph meaning just a collection of nodes and a collection of edges connecting nodes. You might have heard of like the Facebook social graph or something. It's just a big map that connects you with your friends and stuff. It's that structure. Spatial, meaning it sort of sits on top of our level. The pathfinding algorithms take such a graph and find the best path between nodes in the graph along edges. And in this case, the implementer, which is us, defines what best means. And for us, best means shortest in terms of time to walk there, and the one that doesn't guide the character through any walls. That's the problem we're trying to solve here. So we're kind of starting from zero on this. Like, we know how to implement A-star because we can just look it up online. We might even be able to find a Flash implementation if we wanted to, but you can definitely find pseudocode. But how do we get this graph to use as input? Well, that was like the sort of big question because it's a giant thing to generate and we don't really even know how to start. So we've got these dots sitting around on the map from some work that we did with the AI character to make it sort of follow, not path find, but just sort of follow a predetermined path. We had them sitting around from before. So we were kind of like, let's use those. It seems easier than generating some graph from the pixel data. But we still need, aside from the nodes, we need knowledge of which parts are collidable and which parts aren't, which just creates this giant explosion of complexity because there's 500 of these nodes, and if you want to check every possible path, that's 500 squared because you're doing each node to each other node, and it's just a gigantic thing that would take like minutes and minutes to actually run. So really quickly we realize there's almost no hope of doing this at runtime. Like, maybe we could do something where we check a super limited set of nodes at runtime just based on like what's visible on screen or something. But and while that may be possible, we decided that it's probably easier to offload this to some other time and do stuff actually before the player even touches the game. So we were Nina and I were brainstorming at Barcade one night, and we realized this because the graph actually doesn't change during gameplay at all. We can just generate the entire thing beforehand. So I wrote this tool that takes about 20 minutes to run on my laptop. It like cooks forever, and it eventually spits out this thing that's connections between all the nodes and all the other nodes within like a certain distance range, and highlights the connections in red that cross over collidable areas. And it takes so long because each one of these lines is actually, doing pixel perfect collision, which involves generating an image, an invisible image, and then like colliding it again, doing a pixel overlap against the black parts of the background. So it takes forever and it cooks for a while, but it spits out this thing. And then the second stage is it removes all the red parts, and we're left with this pink graph that we then output to a text file that is actually that's like the asset that's loaded during gameplay. This thing isn't calculated during gameplay because it just takes forever, but we generate this text file, and it enables this really nice click over there on the other side of the wall and find your way around it behavior, which was just so cool to see working the first time. But when you click, it actually really quickly calculates the best path and doesn't have to worry about doing pixel collision between these edges on the graph. And this is the giant thing that it generates. This is our, there's like thousands and thousands of lines of each line is one of those lines in the graph, one of the pink lines. And this thing is what's loaded, and loading a text file is a lot easier than generating all these images and colliding them and stuff. So that's kind of where we ended up on that. And the big lesson with implementing that is just offload as much work as possible to offline tools. Do everything that you possibly can before the player actually touches the game, because games are really like a specific game is a very, very limited space for like a possibility space in terms of computation. Like, exactly the range of things that you're going to have to do in a game, even if it's huge. Like, the finite range basically. So quite often you can put together sort of shortcuts that do essentially prediction, like we've done. We know that this isn't going to change, so we just load it ahead of time, and that's like been one of the biggest lessons for me here, because we've just never had to do something of this scale before. So with that, I think that's all I had to say. Our website is cibelegame.com, and I'm Sensitive Emmett on Twitter, and Nina's Hentai PhD. Thank you all.
Do you want me to move into the middle?
There we go. That's what's up. Wait a bit. I guess we can bring up the lights a tad. There we go. Wonderful. Okay, hello everyone. I'm Andy Nealon. I'm the interim director of the Game Innovation Lab that we're all in right now. The format is that I'm going to ask a couple of questions to open this up, but then because we do have a full house, I will move it over to the audience as fast as possible. So I have a bunch of questions. I can't memorize them all. It's actually kind of cool. Like, I was expecting a less techie talk, right? So I know this is called the Tech Talks.
We went all in on the tech.
I know, it's super cool. It's super cool. It's called the Tech Talks, but we somehow always gravitate more towards the creative parts.
Yeah, we never get to talk about tech really, so we were excited and took advantage
Wonderful.
of it.
No, it's super cool, because like that kind of stuff, like when you're talking about the fact that you're using an engine, but then you're talking about stuff that's clearly not supported by it, so you have to roll your own anyway, and then it turns into your own little thing.
Yeah.
Because like, so what is this written in right now? Like you said, you did the prototyping in Flash, you did the A-Star stuff in Flash?
Yeah, it uses Flixel, which
Okay.
is the game
Right.
library that was originally written by Adam Saltzman, and
Right.
now it's open source. And it uses that, like all the sprite rendering and like basic positioning stuff is just Flixel, because it's easy to not write that yourself. And we also use Flixel Power Tools, which is
Have you even heard about that?
it's a set of plugins. I think the only thing that we use it for is the pixel perfect collision. But it turns out that we had to augment that quite a bit anyway. Like that code is now like half mine and half the libraries, just because we wanted to do stuff that it didn't support originally.
Because at some point Nina mentioned Game Maker. Like, was that?
Yeah, we
you
started
dropped that?
it, and it was just like, it was really like, well, it was annoying because Emmett and I like to modify stuff a lot. Emmett more so probably, so we were kind of like feeling tied down by that. And then no video support was like a total no-go. Like, we tried and waited, and we're like, maybe they'll have it soon. And they used to have it. That's the thing. So I was like, oh, maybe it'll come back. And then I was just like, we'll just go to ActionScript and be comfortable.
It kept being like, one of these days, Game Maker is definitely going to have video support. And I was like, no, it's not happening.
And video was too important to like,
Yeah.
leave it out.
You guys were super comfortable with Flixel and that stuff, right? Because you'd made all the other games using that?
Yeah,
All that?
basically.
Interesting. So, okay. how did you get to the point where so you talked about the artist, right? About the artist being stuff. So it sounds to me like you basically see tech. I'm putting words in your mouth now, totally, right? Seems to me like you see tech as more of like a means to an end, right? As like you will accommodate, like your artist comes first, right? Is that true? You seem to like wanted to be. You had that chicken and egg problem where you're like, oh, let's explain to them that we need tiles, but let's not disrupt the beauty of the visuals, right? So there's a lot of tension going on there, but was that fun to deal with? Is it?
Yeah, I mean, I find it to be like a fun challenge. I don't want to be the one who's like, I definitely don't want to be the one who's like, oh, we can't do that. Like, it's just not possible. And like sometimes I have to because I honestly believe that about something, but like, generally I try to just have an open mind and be like, we'll figure out some way to make this work, you know. And I see that like tech is just getting us to that point. I'm not doing it for the programming. Like if I was doing it for the amazing technical challenges, I would probably be doing something else. But like I still find it very rewarding.
So the thing that's interesting to me about that, what you said there, is you both self-identify as programmers, right? I think you both have on your websites like listed like programmer. I'm a computer scientist, and I don't even think about myself as a programmer because I'm not. I'm seriously not. Like computer scientists, professors stop programming at some point. It's sad. It's a sad state of affairs. But you're like, we are like programmers, and yet and I think you even have a background in computer science. Is that true? So, and yet you are entirely platform agnostic, and you're not like, oh, I'm going to do this my own. I'm going to roll my own. I'm going to like write my own engine, because you know that does happen, right? Like a lot of people do this. Like if you've played Dyad or anything of these like ilk of games, like some of the Toronto folks, like they're just like hardcore coders. I think you also had no computer graphics, right? Like I think you had graphics demos on your website. So essentially, you would be technically able to do this. Where does the decision come from that you decide no, let's game makers, let's try this first, or let's use Flash? Where's that come from?
Well, why did we try Game Maker first?
Well, I was like, we're using Game Maker, and I just decided that. I think a lot of it, like, you know, it originally started, I just did the prototype myself and like basically asked Emmett to join me, and I had already decided that we were going to use Game Maker, so he was just kind of like, okay, I'll try this. Doesn't sound good. And like for me, like obviously we've used Flash a lot because we've just used it a lot, and I am more about I am a programmer and I can program, but I'm more about the design. Like I care more about the game, so I'm more of a means to an end person. And I think Emmett's less like that, but when he works with me, he kind of does what I do.
To be fair, I really, really don't like using Game Maker. Like I'm not going to deny anybody the fun of using it and like the ability to make awesome stuff with it. Like I've seen just amazing games made with it clearly, but like personally I just don't like using it because my instinct is to when I don't just understand how something works, I'll read the documentation, and if the documentation doesn't fully explain it, I'll just dig in there to the code really quickly. And with Game Maker, you can't do that at all. And I just ran into wall after wall of not being able to actually know what was going on and having to like reverse engineer their scripting language. And just like with that combined with the fact that we were always thinking maybe we could just use Flash for this anyway, I was just like, you should just use Flash for this anyway.
So why didn't you relieve him of his misery sooner?
I was like convinced it would be faster. I mean, it was a pretty quick switch.
Okay.
Yeah. Like.
Yeah, we didn't spend a terribly long time on the Game Maker prototype.
It's just we started it that way, especially because it didn't support video, and we were like, maybe it will.
Were you just curious about it? Were you just like, oh, let's try
I was
something
also,
new?
I'd heard like a lot of games that I really liked were made in it too. So I was like, oh, maybe this is worth trying. Like it's our biggest project, so maybe it'll help expedite things a little, because I'd seen it help other people in that way. But for our particular game and the particular things we needed to do with it, it just wasn't. It wasn't.
The people I know who are proficient in Game Maker are kind of like wizards of Game Maker. Right?
Yeah.
Like I remember, like when Mark Essoff, right, when he was showing me all these like weird, I'm going to do this crazy rendering, and it's kind of like video art, and it's like, oh yeah, you have a background in video art, and you've like mangled Game Maker to the extent where it's going to do this crazy stuff. Right, or Cactus and all that. Like he was always using this for like crazy abstract renderings that are deliberately obfuscated, and they kind of can do it, or Noah Sasso, right? Like made Barry Bible.
I mean, I'm obviously not qualified to say like I don't even like Game Maker because I barely scratched the surface of it. But I just gravitated towards the tool that I know and like really well. You know, I've also been down the road of attempting to make my own engine. Like in
Haven't we
school,
all?
I tried. I was like, oh, this is gonna be great, and it's just like, what does an engine even mean without a game? Because I got to the point where I was like, oh, I'm rendering stuff, cool. Now let's like support tile maps and like support like sprite loading and stuff. And it's like, I don't want to do that, I'd rather just make a game.
I tried that on my first attempt, and that game never even got made. Right? We stopped when we had the tools. So, okay, we're done now.
I mean, I wasn't even trying to make a game. I was just like, it would be cool to make an engine.
That's an affliction that a lot of computer scientists have.
Yeah.
So about the MMO aspect of this, like, so you guys talked about the nav mesh, or you actually didn't call it nav mesh, but I think that's the going term in the games industry, right? The graph. Like, I know in CS it's a graph. You have nodes and stuff. I think most of them call it nav mesh, the thing that you overlay on top of it. I think they talked about this extensively in the Double Fine documentary. I don't know if you saw any of that. Like their latest adventure game, they showed all here's the nav mesh and here's how the artist actually pretty much similar stuff that you described, only that most of the time those nav meshes are manually created, right? They're just even for 3D games, right? Even for large AAA production, and by making, you mean not writing code to make them.
I mean, I forgot to mention that we did that also. Like those dots on the map weren't automatically generated at all. Like Nina placed all those individually. Thank you, Nina. But the graph was generated between them, but like the nodes were manually placed. Yeah.
It's a super nice insight to know that it's like, this is going to take forever. It doesn't matter because we do it once offline, and then it's just a thing that you load in and it works wonderfully. Do you also smooth the path, or do you like walk along the edges, or do you like try to like somehow like, do you use your old heuristic for the curves to like not like if the graph goes like makes a sharp turn, do you do like a little bit of a?
We're not smoothing them yet, but that's there are a few like little weird movement bugs that I want to fix, and that's among them. Kind of making it less jagged and just make it look more natural in general.
Okay. Yeah. So one more tech thing. State machine. Like you're actually talking about like very pure state machines that have like you have like a label for them. You know what state they're in. A couple of months ago, we had Matthew Wegner here talk about the state machine for Aztez for their brawler, and he calls it. I don't know if you were here for that. He called it a state machine. It was fascinating because basically it's not. It's just Ben can throw in the artist again with artist tools. He can just throw in labels for anything, and then somehow there's always these crazy composite states, right? That a thing can be in can have like also you basically have a huge switchboard. Things can be on or off, and then whatever composite state that it is in, the code has to figure out what to do. Yeah. You seem to opt for a much cleaner approach.
Yeah, I mean that's how it works in AAA games often. Like that's when you need to get extremely complicated with it, that'll happen. And I've like seen how that stuff works, but like I find it so hard to think about that just on day-to-day developing. So I try to just keep it as simple for myself as possible.
And that way you showed is like as simple as possible.
Well, yeah.
How many states so that looked already? I mean, I know what that kind of code looks like.
Yeah.
Because I've messed it up myself before.
Yeah.
But how many states do you have in the game?
I don't know. For that character, it's probably like 12 or something.
Okay, so it's not an absurd amount. And it already looks like that.
Yeah, but I said that it's like a DFA, like it's the theoretically perfect state machine, but it's not actually because we add all this other stuff and like additional sort of side state variables. Like it just gets really messy.
When I was doing that back in college, when I was over engineering my own engine, because that's what we usually did. I had an abstract state class that would call do a thing on it, and then it would bind the actual implementation to the object. And then there was logic at the end of each state call. So I was like, oh man, the logic's not going to be in the main loop anymore. It doesn't matter. It's somewhere. Right? It's like you can't get rid of it. You have to know what the triggers are that cause a state transition. So then I saw students in my game design class doing it a different way. They had like the state machine plotted out on a piece of paper and had like weird bidirectional arrows so it would know what to do when. But basically it was the equivalent of object-oriented polymorphism. So at runtime, you had no idea what was going on.
Yep. That's absolutely right. Yeah, it's impossible to reason about.
So I don't know if did you guys watch the Jonathan Blow programming language talks recently? Because he's basically talking about like how to make stuff super clear. And I think the way you're doing it, like just don't over-engineer it, right? Have discrete states, know it, and just put them in there. And the code may get a little bit messy, but someone just has to stay on top of that.
it's been working for us so far. I'm waiting for the day when it just randomly gets gigantic and none of us can comprehend it anymore.
And we both have to work on that state machine a lot, so like it needs to be simple for that reason too. Because like if I haven't looked at it for like a month, I have to be able to go back and look at it without being like.
So you at least agree on the namings, right?
Yeah.
So that you know at least what's going on there.
Mhm.
Okay, so in terms of design, then, when you have like say 12 or whatever states you're going to have in the end, you said you're trying. Obviously, so the thing that interests me from a design is you're trying to make this other character seem like a real person. Right? You want this to be like, oh, there's another person playing with you, but there's not. How challenging has that been to like limit yourself with the number of states such that you have this version, right? Because you talked, what I thought was super interesting, what you said was the minimal version of an MMO, right? Let's cut away all the fat, like a million buttons, and I have to cast all these spells and whatnot, and just make it the experience that you want it to be. But it sounds to me like you would then have more focus on the characterization of your AI counterpart. So how do you are you already happy with the state it's in now? Are you?
The AI still needs a bunch of work, but I mean it's like going definitely in the right direction. And based on playtesting, people are like, connecting with that character that is like currently an AI. I think because throughout the game there's actually a dialogue happening in the background as if they're on their headsets, kind of on like Skype or TeamSpeak or something. So that helps for one, because it's just two people. Nina is like the one you're controlling, and then you can hear a guy's voice and you see that other avatar, so they make that connection. So they're already thinking of it as a person, which is like a good start. And then I think that's like makes it a little easier on us, so we can kind of like keep it pretty simple. Like we do little things like I think the male character is slightly faster, has like slightly faster speed. So sort of that character is supposed to be kind of like pushy and like wants to be like ahead. So we just like made the speed not noticeably faster, but so that like he kind of forces her to like follow him around a lot of the time, unless she kind of like runs in a different like direction and leaves. So we're doing really simple stuff like that. And like something that we haven't done a lot of yet that I really want to do is what Emmett mentioned with like the tick. So like running back and forth or like running around, jumping, whatever. That's something we still need to do. But I think with the dialogue and like making him attack a little faster, move a little faster, that kind of like people can recognize that personality of like someone wanting to kind of get ahead in that way, or like, does that kind of make sense?
It's great because the dialogue aspect and the design work that we've done to couple people's understanding of this abstract character with this thing on the screen makes the job of the AI programming significantly easier. Like we don't have to do so much stuff in the AI to create that coupling, because we've done it in other ways.
Mm-hmm.
So you've been, and you said you've been playtesting this with like you've given it to people and people are already it's resonating.
Yeah, and like we don't need to do anything like great dialogue on the fly or anything. It's really just the AI like a movement, like so that he attacks things when he should, and like for example, if the Cibele is attacking an enemy, like the love interest character will like leave whatever he's doing and go attack what she's fighting. So like little things like that are really simple. We just like try and like take advantage of all those little things, and that adds up to something that convinces people.
I'm sure you don't want to talk. Well, you say before the talk, you said you don't want to talk about the story too much, right? Because it sounds to me like now we're starting to tread into like I want to dig deeper on this design aspect, but it's like okay, I get it. Like we can actually also leave that to these folks, and then you say no to them.
Yeah.
Not to me.
Well, like that's kind of the basic structure of the game, right? Like you're playing an online game with someone. So obviously there's going to be an interaction in that way where you're playing the game together, fighting the same stuff and whatnot.
And you deliberately opted for voice communication over chat because it's more relatable.
Yeah, and like, well, you guys saw the prototype screenshot with the chat log, and when I play tested that, people responded really poorly and were unable to follow the story. So the decision on that was actually pretty simple. It was just like playtest the prototype and like, oh, text is bad in this case. So that was kind of.
You guys are doing the stand-in voices, or
we hired a voice actor.
Yeah, we did,
but
and I'm doing the girl.
But I do play the body of the guy in the clips. But we don't have we're not doing like dubbed voices or anything. We've just got kind of like ethereal vocals. So there's voiceover with me in there.
Okay, final question for me, because I have so much other stuff here. Oh my god, let's go to that later. Maybe we'll get to this first. So yeah, up to now, the games that I'd played that you both had collaborated on and that you'd worked on individually are like beautiful short form. Like that's what I describe them as,
Thanks.
right? They're just things that they're vignettes. They're very personal, very relatable. They very much resonated with me. They're about nostalgia and loss and trauma and all these different things that are just valuable. So now you're moving to this bigger project. Like, what was the impetus for that? Did you feel it's like we need to do this, or was there just like this idea that you couldn't get out of your head? How did that come to be?
It'd been an idea I'd wanted to do for a while. And as I mentioned, it's autobiographical. So with these like autobiographical games, you'll notice that a lot of the games we've made are about my childhood, like young, like 12 and under. And I could do that because I felt like I had enough critical distance from those experiences to be able to like think about them abstractly and like make something meaningful that like expresses how I feel about it. And with this one, it had been kind of cooking, but I was like, I don't know if I have the critical distance yet. And then I did when I started grad school. So it was like, okay, I did it. I started it as a part of my master's thesis, and now we're like continuing it. And I kind of used that opportunity to be like, okay, this is going to be a bigger thing than we've done. Because I was like, I have what I wanted to explore with this. Because I really have been thinking about it for a long time, like since before I was making games. So.
Okay, I'd love to talk about the future and what you're doing next, but let's pass it on. Let's pass it on to the audience first. I'm gonna hand this around so you can.
So, sort of springboarding off of what Andy was talking about, that you have made a lot of vignette games and sort of shorter experiences, and even with this game, you still define it as a vignette. Like, sort of, what is the play time you're going for? How long do you think it'll take for you to kind of get the message and the ethos of what you're working on across?
Yeah. So I guess usually people's expectation when I say vignette game is like, how do you do it? Which is a minute long, maybe even less. But vignettes don't necessarily have to be that brief. So this one is going to be longer. I mean, it's not going to be like hours and hours of gameplay or whatever. It's going to be as long as it needs to be. And I'm not a fan of like padding things out. With this, like I said about like simplifying, like keeping it down to the essentials is really important to me, especially when telling stories. So I'm sort of with this. I actually like sort of a side goal of it is to show people that vignette games don't need to be so tiny, because a vignette really is just like a character study essentially. So like think of Mrs. Dalloway by Virginia Woolf. That's like a pretty not huge, but like it's a novel. It's like this thick, right? And that's a vignette of one character. You're just sort of experience or reading about this woman's like single day of her life, right? But you can kind of dig really deep on one day, and I think that the same is true for vignette games. So I'm kind of going in that direction. I like being able to make tiny things and things that are a little larger if they need to be, but only when they need to be.
That said, there's almost no time during when you're playing this game when the story's advancing directly. Like it's just always going forward. There's no like exploration time or anything like that.
Yeah, not really.
So you've talked a lot about open source and sort of the value you place on it and all the changes you've made to your tooling. I'm curious if you've contributed any of those back or if that's something you're thinking about.
That's actually a really good contributed back smaller bits that I've done on other open source projects for other games. Like for our game Ladylike, I did an exporter from Twine to the JSON format so that we could import Twine games to other stuff, specifically Flash, and like build something that was a little more than a Twine game, but use Twine as like an asset. And I did contribute that back. Unfortunately, it's called TiddlyWiki. That open source project is not particularly active, so it's kind of sat there and done nothing. But yeah, now that you mention it, there are a bunch of contributions that I've kind of made to Flixel Power Tools in particular that I think could probably be cleaned up. Stuff like, the Pixel Perfect collision detection doesn't support sprite rotation. That seems useful to people, you know.
Thanks. So as for the male player character, or the male character, which is the main non-player character, you said that you had a couple of tricks you had to make it look more believable, and including these ticks, which I found really interesting. It's a very unusual kind of believability, because usually you want a non-player character, to be believable as something that would live in the game world, but now it's believable as someone who would play something with a player behind, which is sort of unusual. You don't see that a lot. So do you have anything else? Can you tell me more about what you did in order to make this look like like it was being played? In some of my own previous work, I've had this thing. I noticed that this thing making it look like it hesitates, for example, is a useful tool.
There's the like emotes.
Oh yeah. So I guess two things that come to mind. What I mentioned before, like making character slightly faster than the main character to express like a personality trait, and also like when she's attacking things, he comes in and helps her out or whatever, joins her. We also have, if you had noticed in the screenshots, there's like a little panel in the upper left with some like kind of faces, like emoticons, basically. So we have the system where the characters can use emoticons, and usually in online games, it's like the actual character model, like doing a pose or whatever. But we prefer to have kind of like an emoji, basically, that kind of like pops up above the head. And you as a player can like click those emoticons to like set off emojis. And we have ones that the non-player character also uses during points in the dialogue, like, you know, from it comes from his avatar, so the player will see it and be like, oh, that's, you know, how he's feeling or whatever, maybe. And also I designed some like specific paths through the level that he will follow particularly, so like it kind of looks like he knows his way around the space already, and that kind of helped too.
Yeah, this, I mean, do you need the non-player character to be generated as you go along, or I mean, I guess quite a lot of it could be scripted.
Yeah, a lot of it is scripted.
Yeah.
Yeah.
I guess so.
It was funny to hear you guys talk about trying to do Game Maker and then beating your head against it.
Yeah.
I feel you. I'm curious, since like it's a little abstract, but since even like Flash is still like at a level above a certain level of computing, I was wondering if there was any times when you beat your head against Flixel or Flash or any layers below that.
It's been really good to us. I can't off the top of my head think of times when I've really been like, oh, if I could, you know, adjust the renderer here or something. One thing that we did notice that again Bennett helped us with was Flixel. I mean, Flash in general by default does all of its rendering in software, and we were just these horrible frame rate problems. It was running on my kind of older machine. It was running at like 9 or 8 frames per second or something, and Bennett was just like, oh, hey, you should turn on hardware rendering. And I was like, oh, I didn't know it wasn't doing hardware rendering in the first place. Like, yeah, but like, you know, it like has that hook. It's like a really weird sort of sideways flag that wouldn't do what you expected it to do based on the name of it. It like didn't just say turn on hardware rendering or whatever. But like yes, I have programmed a bunch in C++, and I know the power that gives you is like kind of just like more sort of tactile feeling is the best way I can describe it. But like, I don't know, Flash has been really good to us for this. Like we don't need to do any insane rendering. We're just drawing sprites to the screen. So yeah.
Okay.
Good. First of all, I'm so happy that you've done this. This is the beginning of our lecture. I'm sorry for that, coming a little far away. But currently, a student online, trying to be part of the screen, and I have a really time doing it online. But I love Flash, so that's something I did discover. I also discovered that I have some pretty interesting, innovative ideas.
Yeah, totally. So I think Emmett's putting it's not. You can talk to us after for our emails, but I would recommend if you're like in New York, I help teach with this group called Code Liberation, and we teach like games programming to women. And we do classes usually at NYU, but we don't have like a central space. But if you go to codeliberation.org, that's where all our classes are listed. I don't know. I don't think we've done any Flash classes yet, and I'm moving to Portland next week. But there's a lot of really amazing teachers in New York, and if you join that mailing list and contact us, I can connect you with people. Yeah, they're awesome. Yeah, we do kind of similar stuff, but more games focused. So yeah, check that out.
Oh yeah. Cool. Yeah, just to pick up from what you were saying before, I mean, one of the main reasons why you wouldn't use C++ for something like this is video, right? I mean, so Flash, for all the reasons.
Yes, yeah, that's a huge reason, yeah.
For all the reasons that you've been saying, Flash is so broken and weird. It's like a lot of the defaults, like the hardware acceleration, are not what they should be.
Yeah.
Often for kind of archaic reasons. Yeah. But it has this amazing video support, I guess, because it was used for advertising.
Yeah.
It had full motion video on the web before anything else did.
That is actually like the number one reason that we just completely discounted something lower level, because it's like, well, how would you do this on Mac, Windows, and Linux?
Right. So my question was, did you look into what the video options would have been? I mean, you said there's nothing in Game Maker, but what else is out there? Because you don't even see it in games, especially indie games anymore.
That was something that really bothered us, because first of all, we were looking at all these engines, and it was like, they don't even support video. Like they're putting our games in a box, right? Like,
well, also Unity does, but only if you pay for like the most expensive version, and we just couldn't afford it.
And so like if you were going to do it in C++ or something, you would have to like include different formats of the video that worked on Mac and Windows and Linux, which is like doable, but it like also kind of turns the project into make a cross-platform video player, which I would do if I absolutely had to, but I would rather just make a game. And Flash is just like, you can just have an H.264 encoded video and just drop it in there, and it just will work, and that's awesome. Yeah.
Hi. You mentioned, stripping down like what an MMO is in order to like sort of tell your story and not really make an MMO. But you also mentioned combat. Like you mentioned that the AI character like gets in fights and sort of like there's like an expressive quality to who he fights and when.
Yeah.
So did you put a combat system in this game? Like, is there a?
It's also very stripped down. So the whole game is point and click. So like, yeah, we said before, movement is point and click. The whole sort of like combat, I wouldn't even call it a system, but the combat is like point and click as well. And basically, like you probably saw in some of the footage, it's just like there's some enemies around, and it's just like click to engage. Kind of like, because I play Final Fantasy Online, and that's basically what you did in that game.
So
you
far
just
off.
click. So it's like, also it's pretty accurate as to what it's actually like, minus all the like casting spells and like whatever. And we didn't show any of it, but some of the animations suggest like magic casting and whatnot, sort of give it that atmosphere. Because I was like obviously influenced by Final Fantasy Online because that's what I played. So we wanted to get that vibe. So it looks like she's casting magic, but you don't need to go through like menus and layers of menus and whatnot to do it. It's like very straightforward point and click stuff.
Cool.
Yeah.
Wow, I'm lazy. I can't even get up. Okay, so then I'll close it on two more things. Congratulations on your IGF nomination for how they do it. Yes, please.
Yay.
So that's for the highly coveted Nuovo Award. That has how many nominees? 8, I think.
Something like that. Yeah.
7 or 8. Right. So I guess you're going to GDC. Right?
Yeah.
Hopefully. Yeah, I'll be in
Jenny and Alec too.
I'll be sitting there somewhere. Are you guys okay?
They got nominated for student IGF. Yay! And Steven's not here, I guess.
Right. Yeah, NYU got a lot of love.
Yay.
I think 3
So
of the student
exciting.
nominees are NYU projects
Mm-hmm.
for the first time. Also, that's amazing. So congratulations to all the people at NYU that got into there.
Totally.
And secondly, and lastly, you are moving, as you just mentioned, next week.
Yes.
So to work with Steve Gaynor
Mhm.
on Tacoma, I assume.
Yeah.
How do you want to talk about briefly how that came to be? Because my view
Sure.
of how that came to be was he hired you on Twitter
Oh man, I'm
for
gonna
like
tell him you
a
said
year.
That's really
Basically.
funny. No, okay, so We met at GDC a year ago.
Okay.
And that's like, I guess, the short version of it. I was showing How Do You Do It and Ladylike at the Unwinnable House. And if you guys haven't checked out Unwinnable, they're really awesome. They do like games, journalism, and
They have like
cool
a regular,
writing stuff.
They have a regular thing now, right?
Yeah, yeah.
Like
They
weekly,
had
the weekly.
Yep, and they had like a Kickstarter project for it. It was really
It's
exciting.
already at number 20 something, and I've read yeah.
Oh no!
Yeah,
their stuff's really good.
So much stuff to read.
You should read it. So I was at they have like a little sort of party where developers show their games, and I was showing How Do You Do It in Ladylike, and a lot of people were there, including Steve, and we met at that party, and he was into How Do You Do It in Ladylike, and then things kind of went from there.
Sounds like a natural fit, right? Because your
Thanks.
exchange on Twitter sounds like you've known each other for like a decade.
Really? I guess we both are very active on Twitter.
No, it's like I was just like, oh, what's Steve up to? Oh, they're having a conversation again. But
That's funny.
But it sounds like you guys have been talking about this for forever. So
yeah, it's been in the works.
Did he like? How long has this been in the works? Like, has he like? Was this like a couple weeks ago? He was like, hey, by the way, what are you doing? Because you also just graduated, right?
Yeah, that's true.
So a lot of stuff.
It was before I graduated. And it was like after I graduate, I'm gonna go to Portland, work with them. So
Awesome.
yeah, I'm excited.
Nina just came back one night and was like, "Hey, you want to move to Portland?"
Yeah.
All right, yeah.
I heard it's amazing there. I've never been. So.
Yeah, it's really, really nice. Pacific Northwest is just really beautiful. It'll be very different from New York.
Probably. I got Steve's offered to house me. Like, whatever. I'll do it. I'll get there someday. I've also never made it to Toronto. It's really embarrassing. So very like indie places where like a lot of people congregate. I've just never been there. So anyway, okay. So it's great for you. Obviously, we'll miss you in New York, right?
Yeah.
Like, 'cause it's like you've been like grew up here. It's kind of an asset. Like
it's
maybe
crazy.
you want to come back someday, eventually.
We'll be back. Can't keep us away from New York.
Okay, sweet. Well, thank you so much for doing this. This has been amazing.
thank you.
So please help me and thank you. All the
Thanks,
best, all
thanks
the best
Ben,
future
for
projects.
organizing, and Andy as well.
So
Really
yeah.
appreciate it.
Very curious to see what comes out of this. So you're gonna be working on 2 projects. Right?
Yeah, it'll be fun.
Great.
Yeah.
Okay. Thanks, everyone.